Yep,
You got no
especially
actual.
the thing they say that disappears behind the curve. They have no clue what it is, how big it is, what it's made of, absolutely how far it is. They have absolutely no clue. All
Oh,
speculation.
the sun. Yeah, I mean, geez, look at how they changed the distance to it. 3 million to 93 million. I mean, were they wrong before, or were they just inaccurate? If I go measure a board and come back and tell you it's 8 feet, but it's really 12 feet, was I wrong, or was I just not accurate enough?
Uh huh. It's just a belief system of an establishment that has to have an answer for everything because, after all, the funding goes to them, right? If you're a
Yeah, you
physicist, an
only get funding.
astrophysicist, you're going to make shit up to to keep your funding, right?
Well,
What are you
they'll
going to
only
say?
give
Oh,
you
we
funding.
got it wrong.
Yeah, no, they'll only give you funding if you go with the mainstream narrative. If not, you're getting blackballed, blacklisted, no more funding, no more tenure, whatever they got going on. They just get ruined by it. It's happened a lot.
Yep.
That's how they
Hey,
do you if
Dark.
you go against the mainstream paradigm, the mainstream narrative. They'll just crush you.
Yep. Somebody brought up dark matter before, right? I think it was you, Jeremy.
It was.
Yeah. Something they say, listen to this now. You can't see it. You can't touch it. You can't measure it. You can't interact with it,
No.
but it's there.
And it
Well,
bends.
light's interacting with it. Light's
Apparently.
interacting. It's causing light to bend.
No, no, no.
Oh, it's dark. That's why it's dark. It doesn't interact with it.
Yeah, but it's just a speculation. The light is doing what they say, right? What they observe. But what they
You don't.
say is doing it. You can't measure it. You can't touch it. You can't see it. You can't smell it. You can't interact with it. Get the problem?
No, we don't even know if it's doing what they say it's doing. You just see a light in the sky and say, "Oh, this is what it's doing," because dark matter. You can't prove that it's actually doing that. There's none. They say they don't. They say that the dark matter bends space time, and the light follows the space time, therefore causing the light to bend. If you want to get semantical and say it doesn't interact with the light or whatever, fine, but it does cause light to bend.
It's fantasy. It's sheer and utter
In their
fantasy.
model, it causes light to bend. You don't even know if that's what's actually happening or not.
There's a distinction between light bending and light interacting with it. EM radiation.
What's the distinction? Are you saying light bending is not interacting with anything?
What I'm saying is, if it was light interacting in the sense that they're using, it would be absorbed, it would be reflected, it would show a color, and it not necessarily be visible light. It might be, you could detect it using X-rays or infrared or some, gamma rays. I mean, it would show some wavelength. There would be a, reflection, so to speak. There is no reflection in any wavelength
Of what?
of light.
To what? Well, I'm not
By
following
dark
you.
matter. In other
You're
words,
saying you're saying light does not react with something that we can't see, touch, smell, or detect or measure?
that's kind of the definition, yes.
So do you not see how absurd that is?
No.
You're kidding me, right?
Nope. I see it makes perfect sense to me.
Okay, let me put it to you this way. I'm driving down the road, right? And I see like something isn't like, let me put it to you, something stops me, bang, dead stop. I'm not going fast, I don't get hurt. But my car, I get out and I see damage in the car. Right, I bring it to the garage and you come there and you ask me, what the hell happened here, bro? I go, I don't know, I was just driving down the road and bang. But what hit you? Dark matter. And you're gonna tell me how did it look like? I don't know, I couldn't see it, I couldn't smell it, touch it, measure it. What would you say to me?
My answer would be, it had an effect on your car. It caused damage to your car, therefore it exists.
You wouldn't think I was crazy? Like maybe you'd say, were you drunk? Maybe you hit a pole? Or maybe you hit a car?
He should be
You
a
wouldn't start
claims
off
agent. Yeah, he should be a claims agent.
yeah. Yeah.
If there was other evidence of it being a pole, maybe, for instance, damage to a pole, maybe some splinters in your car,
Or would have to be something tangible, right?
there would have to be something tangible. Yes, you're right.
Exactly. Well, this dark matter, it's not tangible.
No, that's
In the
the
very
distinction I'm making.
explanation of, sorry?
That is the distinction is it warps space-time. That is the tangibility of it.
No, you first of all, you're making up space-time. That's another fallacy right there. Space-time, what is that? What is space? What is time?
Okay.
And you're saying that this thing now somehow warps something.
You can see its effects on the surrounding environment. How about that?
I can give you that you look out and you see something happening, right? You
Well,
look through
there's
your
multiple
telescope
effects.
and you see something happening, correct?
Yes.
Okay. And then, first of all, let's get to the crux of it. All this happened. You know why all this happened? Do you know why? This dark matter, do you know why?
Because galaxies weren't behaving as they should be.
Exactly. So now, they looked up with their telescopes, and what they previously thought these lights should be turning, they found out, according to their current theory of gravity, right, that it was wrong, correct? That they weren't behaving according to the model, correct?
Basically, what they were seeing is the amount of matter that was visible in what I said earlier, X-rays, gamma rays, light, infrared, all of the visible matter did not account for the motion of the galaxy. So there was some dark force causing a discrepancy in the motion of the galaxy.
Well, you're running now, you're running. So I was correct in what I said. They observed something, they observed lights in the sky, which previously they thought should have been rotating at a certain speed, and they found out they weren't, correct?
I mean, they always knew the speed. The discrepancy wasn't in the speed of rotation in terms of what it was before and what it was after. The discrepancy in the speed of rotation is what is causing that speed of rotation. It's
No. Whatever was happening. Nothing changed in what was happening.
Correct.
You agree with that, right?
The speed was always the same, yes.
Okay, so, but what they were perplexed about is their explanation to the lights in the sky was wrong, correct? According to the current model they had of gravity, Newtonian gravity, correct or incorrect?
Correct.
Okay, so then instead of saying something is wrong.
One small thing, I think it was the Einstein interpretation of gravity, not Newtonian.
It was the Einsteinian interpretation.
But small discrepancy. It was gravity. We'll go with that.
Okay. We'll go with the bending space light then. That one, right?
Okay.
Okay, whatever. Whichever one, it doesn't make a difference, the point I'm trying to make. So instead of saying this theory is wrong, right? And stepping back and saying, wait a minute now. Maybe it's not this bending space-time or matter attracting matter, whichever one it was, doesn't matter. Instead of doing that, they said, shit, man, maybe we should make something up, call it dark matter, and make our calculations work. Isn't that what they did?
That is actually, they've done both, as a matter of fact. They did come up with dark matter, but they've also come up with options that say gravity is wrong.
But why didn't they start off with that premise? Instead of coming up with a cockamamie idea, why didn't they just say, you know what? This is wrong. This bendy light shit is all wrong. Let's start from scratch, and let's just say we got it wrong. Why didn't they do that? Instead of coming up with crazy stuff like dark matter, dark energy.
Because it works on planet Earth for the things that we use it for.
What works?
Newtonian physics.
But
And
it doesn't
Einstein.
work. It doesn't work everywhere, does it?
It works on the Earth.
Basically,
But wasn't
he
it
said-
replaced by another physics? Wasn't it replaced by Einsteinian?
what I was going to say is he's saying Einsteinian or whatever, Newtonian, gravity works locally, but it doesn't work on astronomical scales quite the way we think.
No, whatever you call gravity works perfectly just fine the way it should.
Locally.
The smartasses called Newton and Einstein got it all wrong. Isn't that a better description?
No.
I think it is.
Gravity works perfectly well locally within the solar system, even within our own galaxy.
What is gravity? What is gravity?
Well, I don't want to go in circles on that. We'll say the modern theory, whether you agree or disagree with it, it is the accepted theory on the local level within our
Which
own
one,
galaxy.
the Newtonian or the Einsteinian?
Depends on what you're using it for.
So we can pick and choose, like.
You can. Depends on
Have
the
you heard
accuracy.
of the term dialithysm?
It depends on the accuracy you need. Because again, to be clear, Einstein is actually a special case of, sorry, let me say that again. Newtonian is a special case of Einstein in that Newtonian, they both predict the same things at low speeds and normal gravity. The difference between the two is that Einstein is more accurate at higher speeds and at higher gravity.
So what? They're both wrong.
Okay, I mean that could
None
be
can
true.
be. You can't prove either one of them. They're both wrong, and I explained to you how. They're so wrong that they have to admit that 95% of what we see there is not visible dark matter, dark energy. The explanation they're giving you is for 5% of what they think is out there.
Not the local level, is it?
Everything. What they say, what they call the universe, they're giving you the explanation of what they think 5% is. And you see how wrong they got that. Look, I'm sorry, man. I don't want to put darkness in the situation, but I'm just telling you the facts.
So, did you ever hear about the supernova that they predicted?
The one that reoccurs all the time? That one?
Not reoccurs. It doesn't continuously reoccur. It only reoccurs due to certain conditions. So it won't reoccur like every year. I mean, it's not going to be a yearly thing or anything like an eclipse.
So if you look at it and for a while, and then you can predict when it's going to happen again because you've seen it happen. I mean, is that really a prediction?
But that's not the case. It's not a cyclical thing. It doesn't happen every day, week, month. It might happen 30 days from now. It might happen 78.5 days from now. It might happen again 163 days from now. I mean, completely random. It's
And
not
your point
predictable.
is? And what's your point?
Is if we predict it and it's completely random, how do you explain that?
First of all, you have to show that you predicted it and that it's completely random. You just said it occurs more
At
than once,
random
right?
intervals.
So how?
Yes.
Yeah, so somebody could figure out the pattern. I mean, you find that difficult to understand?
But what's the point is, if there isn't a pattern, how do you predict it?
Well, you tell me. I'm not the one bringing this up. I don't claim this to be true.
You have to if there's not a pattern, you have to understand the cause. That what causes the randomness.
Oh, I'm glad you said that. Cause and effect. Go ahead. You tell me what causes a supernova, please.
Well, I wasn't going to get into the cause of supernova. What I was going to get into
Of course you weren't. Because you
Hold
have
on.
no clue of what you say. You're just saying stuff.
I was going to get into the cause and effect of how you can predict the supernova.
Somebody told you that you can predict it. You heard it somewhere and you're repeating it. That's all you're doing.
That is true. I
Yeah.
didn't predict it myself.
You're passing by what I told you, bro. We're talking about gravity, and I explained to you they got both of them wrong. They had to come up with this dark matter. They had to admit that they know nothing of 95% of the universe, right? They got 5% of the universe wrong, and you're telling me now about a supernova? Really? That's your answer to what I just said. Like you didn't say like, wait a minute, what the hell? Really?
I was going somewhere with the supernova thing.
Oh, go ahead then.
Please.
Because they saw a supernova. It occurred, on day one. They said, due to gravitational lensing and how this particular light will travel through the universe and get bent by other objects, dark matter, whatever, we will see this supernova, the light from this supernova, we will see it again in 2 years or whatever the time frame is. They got that down to within a day or two of seeing it again from when they predicted.
Wow, very impressive. Okay, and let's assuming that happened, which I'm willing to bet anybody that didn't happen like that. But let's assuming that happened. What's your point?
That the understanding of gravity and how it bends light, that's a demonstration of it.
So you're saying by bending of light, they were able to predict when a supernova was going to happen again? Is that your claim seriously, bro?
By
So
understanding,
I'm going to look into this.
By understanding how the light was bent and took two different paths. To be clear, there was a direct path between us and the supernova, or at least more direct. There was another path that kind of went off at a different angle, got bent back around to us, and took another path and took longer to reach us, 2 years or later, or whatever it was. But they knew that path. They understood based on maps of the gravity of the environment, whatever is there, stars, dark matter. They predicted that it would show up 2 years later.
Okay, so let me get this straight now. Based on gravity, the two gravities which I proved to you were dead wrong. You're telling me that they were able to use gravity and bending light to predict a supernova, and you're happy with that? This is what you came with?
Yes.
Bro,
Yeah, to
if
be
you
fair,
were a
I
lawyer, I
don't-
would not hire you.
Yeah, I haven't seen you prove anything wrong, SC. We've talked about some things, but you haven't proved anything.
What am I trying to prove?
I don't know.
So you just thought you just talk like that?
No, I
Gravity.
just,
You're trying to prove gravity's wrong.
yeah, you said you disproved something, but I haven't seen any proof of anything. We're just having a
So you
conversation.
don't agree with what I said about Newtonian and Einsteinian gravity? And as we were talking about what he brought up about the arms, and we agreed that they got it wrong, you disagree with that part?
Yeah, I disagree with your interpretation of the situation. Yes, I do.
So then, congratulations, you're disagreeing with current scientific opinion.
Okay.
So wait, hold on.
You're anti-science then.
Hold on. To be clear, he is agreeing with the accepted model of gravity. You're disagreeing with the accepted model of gravity, and he's the one that's anti-science?
Yeah, because the agreed model of science, the current one, not the both that you guys are championing for, the current one, right, the Einsteinian one, doesn't work with the galaxy rotation. I showed you that. We proved that by not me proving it, by your own model. They had to come up with dark matter for that.
Okay.
We agreed on that.
So your proof that Einstein gravity doesn't work is that the galaxies aren't spinning the way they should.
Exactly. Not my proof. Your model's proof.
Okay.
I just have to sit back and show you your own model how it doesn't work. Very easy to do, man. I just did it.
Okay, now I understand. I got it. And by the way, I did say that there are alternative theories to explain that. One would be dark matter, but there are other theories that do actually change the way gravity behaves at certain distance scales.
Hey, I'm open to suggestions, but I'm just making it perfectly clear that Einsteinian gravity does not work. He was wrong. The warping of space-time is wrong.
I think I would go with incomplete. On the right track, but incomplete.
Yeah, you're free to. I'm just giving my opinion, by the way, right? I'm just one person. You can believe whatever you like. Just don't try to convince me of it. That's all. That's all I ask.
So, okay, we'll go with that. If Einsteinian gravity doesn't explain the rotation of the galaxies, what are possible alternatives?
Well, we can get into speculation now, something I don't really care to do because anybody's idea is just as valid as the next guy.
Well, the problem with I mean, you can't just say random pixies, are doing. I mean, you gotta, if whatever idea or possibility you come up with, it has to, number one, explain the existing environment as good, if not better. And number two, has to make and explain what is currently unexplainable. So it has to do better than the current theory. You can't just not explain the current, but only explain what's unknown.
You're going by the rules that's got us in this place in the first place. No, thank you. No theoretical bullshit do I need to debunk. It's theoretical for a reason. Why would I need to replace it with something that's a better theory or a theory that works more in the theoretical nonsense? I mean, they're working on things now that no one even thought of.
That's
To
the whole
replace
point.
dark matter. They just came up with dark matter and they're already trying to replace it.
That's the whole point of science in general, is every idea or theory you come up with is better than the one before it.
So the
There's
story
much-
can just get better and better, but the truth is
Well,
unknown, right?
Well, there's much uncertainty on the fringe, on the frontier. I mean, there's going to be things that are inaccurate and that are advised, and as you develop and get better and better, you're going to make mistakes. So I don't think it's a perfect where everything's exact.
So why do you fear? I want to hear you say it. I bet you won't say this. Bet you anything. I want to hear you say, Left Lane, Einstein was wrong.
I can't say that with any confidence. No.
I know you can, bro. I know. You guys are brainwashed, man.
Dude, I'm not qualified to refute Einstein.
And again, I said it earlier, it's not that he was wrong, it's that the theory is incomplete. It doesn't explain everything.
No, he was wrong. He was dead wrong. Not only wrong, dead wrong. Dead wrong. They had to make up 95% of the universe to keep up with the current theory. They pulled the wool over your eyes.
They even
By your
call it a
own model.
mathematical filler. Like it's a filler
Yeah.
to make the math work.
I don't disagree with that part.
Well, when you're 95% wrong, if you got 95% of the test questions wrong, what grade would you get? Would you get a failing grade or a passing grade?
That would be a failing grade.
Yeah, I would say he was wrong then, right? When you take his theory and you have to fill it with 95% dark matter, which is a mathematical filler, the scientists agree, are trying to say, they agree that it's a mathematical filler, it's an unknown, then I would say his theory is wrong, right? Wouldn't you?
As I
That's
said,
why. Pretty incomplete. I mean, you call it incomplete.
yes.
Yeah, I might would write big red letters across your test paper, incomplete, if you got 95% of it wrong. Yeah, I might do that. It's still wrong. You can make all the fancy words you want. You can use incomplete all you want, but it's still red letters across your failing test, your failing theory. That's all we're saying. Current science is saying it now.
I think part of the problem is you guys think that's a bad thing, that his theory doesn't explain dark matter or these discrepancies or whatever. And actually, most of science actually thinks that's a good and interesting thing.
I think you just put that in there because no one said it's a good or bad thing that I've heard. I've just heard that why do y'all fight for Einstein to be right so much when obviously he's wrong about this? Obviously a brilliant guy, right? Like, I mean, his theories are pretty cool. They've proven to be wrong. Let's move on. Let's try and find out what's right. Truth. Why are we still trying to apply Einstein's theory to things we know don't work?
Do you have an alternative theory?
That I was about to say that.
Why
That's
why
why, Rakia. That's why. That's your answer right there, because they need a replacement. Otherwise,
Yeah.
they're unable to think for themselves, right? Like,
Well, that's the whole point of refuting something. Is you can't just say no. You be able to replace it.
Okay, y'all just keep on saying Einstein's right and don't find any replacement for it yourselves and just blame it on us. I mean, I guess the people who are pointing out that it's wrong. Is that how science moves forward? I don't think so. I think you're part of the problem, actually.
So, to be clear, nobody in this chat is finding a replacement for Einstein's theory.
I don't think no one in this chat is capable of finding a replacement. All of science can't do it. Why would you expect SC or me or Left Lane to do it?
No, I don't.
Yeah.
Nobody in this chat, but science is capable of doing.
I don't know that. Science is the current science model. Moving away from cause and effect is why we're in this position. All this theoretical nonsense, building on theory upon theory upon theory, is why we're here. It's why people think they live on a spinning ball. Quite frankly, because of relativity and gravity and things like that are you don't know the cause of and can't prove. It could be something else, but we're not researching. We're not putting our efforts and thoughts and consensus and finances into other reasons. We're just building upon the current theory because we've deemed it to be the best one. That's not science, man.
Just because you don't have a replacement for it doesn't mean you have to keep something that's wrong. That's what you guys don't understand.
That's like having a girlfriend that beats you up every night, but you keep her because you don't have another girlfriend to replace it. It's dumb.
Well said, Rakia.
Kick that bitch to the curb.
Yeah.
See you later. And then once you get that nonsense out of the way, it might become more evident to others that, hey, he needs another girlfriend, so I'll introduce this and this and this, right? Now, relate that to science. Kick all that nonsense to the curb and let's start looking into what we see. Electromagnetism, superfluids, how the energy ignites things, how energetic our atmosphere is, how if the sky is a superfluid, a frictionless fluid, how it would affect how we see into the distance. They're already looking into this. I don't know why y'all don't talk about it more. It's amazing. And oh, by the way, they did talk about superfluid being in the atmosphere a long time ago when they came up with the Big Bang theory. Guess what came out of the Big Bang first? That's right, boys and girls. Superfluid.
That's actually not a okay. So if it is a frictionless superfluid, what effects or what would you notice about the lights in the sky?
The same thing our forefathers and forefathers before them noticed. They're moving.
Okay. Now that's yeah. So
And not only they're
where
moving,
is the
let me
boundary?
one more important thing, and I'll let you go. They're moving in a pattern.
Yes, I agree with that. So where would the boundary be between this superfluid and our atmosphere?
Who
And
knows?
hold on. And how would you detect that boundary? How would you know where the boundary?
We couldn't. Me and you could not. That's the answer to that. Me and you could not detect that.
Okay, you normal people can't. The question is it possible to devise a test that can? Other people with more resources can do so.
Yeah,
Perhaps.
maybe if we quit
Perhaps,
telling all the universities and students that come up and read these books and do the same test over and over again, that those are just theoretical stuff and they might research other ways, right? Like, as the current model goes, I don't think we'll ever figure out those questions.
Well, I mean, I'm kind of going, one obvious way would be you just keep sending probes or whatever higher and higher. Now, there's a limit to how high you can go with your given money and fuel and whatever. But you can keep going as technology improves. You can keep going higher and higher.
Again, under the current system, I don't think that's possible because we're giving our money to a government agency who, if is keeping things from us, they're not going to tell us what they found when they send things higher. They're already saying they're keeping stuff from us for national security, and now they're saying, "Oh, we landed on the moon, but we didn't go back because of what we found," and all that propaganda BS.
So it's not just, first of all, it's not just the U.S. government. It's all different governments, but also there are private companies that do this now.
Really, bro? I mean, seriously.
I mean,
Yeah, if you say Elon Musk, I'm going to quit talking to you. Because
well,
you
I was
don't think
gonna
he's
say
control.
Bezos and Musk are a couple, but there's also the guy from Britain, the Virgin guy. Virgin
Oh,
Galactic.
God.
But again, it's not just the U.S. I mean, it's all different countries. Some countries have their own independent space agency. But again, what I was saying is, you can send, probes higher and higher. What about sending a laser beam? They have what's called adaptive optics. Have you ever heard of adaptive optics? Basically, nobody answered. But anyway, basically, adaptive optics is something that they put on telescopes. Essentially, they shine a laser beam from the ground through the atmosphere toward whatever they're looking at. And this laser beam.
I know what that is. Don't think we don't know what that is. It corrects for the atmospheric disturbance.
Right. And I've got a quick explanation for those that might not know. Is it shoots a laser through the atmosphere and, as he said, corrects for temperature differences, humidity, and basically it allows the telescope to focus the image as if the atmosphere weren't there. Or pretty close.
And your point is?
So that laser beam, it detects changes in the atmosphere. Now the question is, how high does it go? And where would it detect a change from this atmosphere to the superfluid?
Well, do you know where they claim that laser ends? Let's start off with that.
I mean, it doesn't really have an end.
Are you sure?
I mean, it goes through the whole atmosphere, 50 miles, whatever, 100, I don't know.
So you haven't seen the pictures then, huh? The green laser?
I mean, I've seen them. They go a long way.
But do they go on forever, or do they appear to stop somewhere?
they appear to stop somewhere, but I mean, it's not like a lightsaber. It doesn't have a beginning and an end. It's a beam of light.
Are you sure?
Yes.
All right. Have a look at what you're saying. Do a Google search right now.
I know what you're talking about. That the little green laser goes up in the atmosphere and just stops.
Yep.
But think about what that means. It's kind of like if you have a dusty room and you shine a flashlight through a dusty room, you can see the light, but it still keeps going even once it's past the dust part of the area. It keeps going. It doesn't just stop.
Okay, so what's your point? I tell you, go have a look. I was surprised to see it myself, but go have a look at what you just brought up, the green laser, the one that they point to the Atmos, and the one that is, makes it clear. Have a look at how it looks. It looks like a saber, a lightsaber.
So you think that it just stops? It goes for 50 miles.
I
and the
said
beam of
how
light
it looks.
spins.
I didn't say that. I'm just testing your knowledge of it. That's all I'm doing.
I know exactly what you're talking about. The little green laser, it goes up and then just you can't see it anymore at a certain point.
Yep.
I know what you're talking about. But that
Okay, so what's your point now? Okay, what's your point? Now that we established what it is, what does that prove?
My point is just because it goes up so high and you can't see it anymore doesn't mean that the laser beam isn't going further. And the whole point of this is, could that laser beam detect the boundary between the edge of the atmosphere and this superfluid that exists?
Well, as a matter of fact, that's why I brought this up. That's what they claim. The people that shoot this laser say that it reaches the edge of the atmosphere, the part that's waving back and forth, that's blurry. That's not my claim. That's what they say. Yeah.
So so the edge of the atmosphere and then this superfluid just starts right there.
Don't put words in my mouth. I have
That wasn't a statement.
What it is. You brought this up. We're just talking about the laser. I have no clue what the Atmos is. I have no clue where it ends or what's beyond that.
My whole point in this is, how would we determine if there is a superfluid? Rakia brought this up. Is there a way, again, theoretical or practical, to determine if there is a superfluid out there somewhere?
Yes, there is one way and one way only.
How is that?
If you had the budget of the US military, access to all the technology, then you will be able to determine what's up there, quote unquote.
But how would you do it?
Until you do that, you will be dependent on somebody else's opinion, and you will be lied to. That I can guarantee you.
But that didn't really, the question is how? What method would you use? Would you personally
shoot a rocket up? You send a freaking rocket up.
There you go.
Simple.
So you would visit it personally. And to you, that's the only way to do it. We have to go there personally and see this for ourselves.
For me, no, not personally. I would be satisfied being there with the rocket, seeing the technology, being in front of the screen, seeing the lens, all that stuff. If I was there.
So not you personally, but somebody in person.
No, me personally. Me.
So you personally have to go there.
Yes. You're asking me, right?
That's your standard of evidence is, as a person, you have to be the one that goes and sees this boundary for yourself.
Yep.
And nothing else will convince you.
Nothing. Absolutely. Not this government that we have today that we know lies to us on a daily basis. Absolutely. That's it. Yep.
But I'm not just talking about personal in-person, going there personally. I'm saying other remote tests. If you shine a light, you can see, that was the whole point of the whole adaptive optics. You can see the difference in how that light affects its environment, and it will transition. If you shine it from water to glass to different elements, you can see a transition between those different things. And, you can use different spectrums, you can X-rays, infrared, all these different things. You can take different pressures, different measurements of perhaps pressures. Again, that
You're
would
just saying
probably
words. You're just saying words, bro. You're just throwing stuff out there.
My point is, it does not have to be a personal visit. You can take. There are
Maybe
ways
for
to
you.
analyze data.
Look, bro. For you, that might be sufficient, but you asked me, right? What's my standard? And I told you.
Okay. And that's. I mean, I'm not saying you're wrong. I'm just saying that's not how science works. Actually, science doesn't require a person to personally go somewhere and check something that's real.
Right, because you're convinced this quote science unquote, right? You're convinced that what they tell you is true and the trick has been played on you, bro. You just don't realize it. You're
I'm
not
not talking
capable
about-
of understanding what I'm dishing out here, bro. You're
I'm
not
not talking
capable of
about-
understanding.
I don't mean science like astrophysics. I'm talking about any kind of science in terms of or even expeditions. I mean, the Mariana Trench, do you have to personally go to the Mariana Trench to know that it exists?
No, it won't. It
What
won't
was that?
change my life whether it exists or not. The Marianas Trench doesn't matter.
But that's my point. Is that's part of science. Is somebody's been there. Somebody has taken the measurements. Somebody has the video, the recordings, the pressure readings, the life that exists there. Somebody else has done that. The rest of the world accepts that that's true without going there personally.
Right. Now, I've seen that footage that you're talking about. I've seen a lot of those deep, and those things look real to me, absolutely. I will not dispute that. Not one iota. I've even seen one of the bubble one that went underwater and it appeared to hit like a wall that was invisible, and they said it was a different salt content or whatever. That's real. You can see it. That's good enough for me. Now, the other stuff, that ain't good enough for me. It looks fake as shit. That's just me. Now, if you want to accept it, Extremesis, be my guest, brother.
To me, that just seems like a little bit of a double standard, that you accept something that looks real, that people have proven, and other people, let me rephrase that. There is evidence that the Mariana Trench is real. People have been there. They have footage. They take the pressure readings. They have I guess they've probably taken life samples, whatever. People have been there. You accept that.
Yeah, it's an ocean. It's a water with a hole in it, bro. Yeah, I accept that. What's so hard to believe about that? You have an ocean, which I've been in, and there's a deep canyon underneath it. What is so hard to accept and understand about that? Why should I question that?
Because you've never been there personally.
Okay. But I can go there, right? Tomorrow, if I choose,
No,
right?
You cannot go to the Mariana Trench. You do not have the ability to do that.
Yeah, but I can go to the area. I could like scuba dive a bit, look down and say, holy shit, it's pretty deep there, man. Yeah. Sure, I can do that. Why not?
There's a difference between going scuba diving 100 feet and going 7 miles down.
Okay, agreed. So are you telling me now I can go to a spot where they say it's an ocean? I could go to that exact spot. I could look down and I can see a canyon. And you're telling me now that's the same thing as in space?
What I'm saying is, you have not been to you can go to the area. Okay, so you can go to the area and you can look at the area and see it. Now, if you're going to go to space, what's the closest thing we have to space that somebody has been? Now, you could probably say
not somebody.
Well, I'm going to start.
Can you go to the ISS, for example?
Hold on, I'm going to start small. The first thing I'm going to say is the closest
ISS.
Let me build up on this before you ask that. Okay, hold on.
Bro, you're wasting your breath. You're trying to compare water here on Earth to space. It ain't gonna work.
What
Save
I'm
your
saying
breath.
is, I'm
There
gonna
is
compare-
no comparisons.
Hold on.
Rakia,
Absolutely none.
his argument is that because you're saying that you only believe in things that you been there personally.
That's
Now he's
kind of
making
my argument.
he's
Yeah,
ma-
belief. Yeah, it's my belief, and I'll say it. I can't prove it though. It's just a belief. If you wanna get me on that, you win. Yeah,
Hold
just a
on.
belief.
I'm kind of doing this a little bit at a time, step by step. So your argument was you can go to the ocean at the Mariana Trench. You can look around and you can kind of see down below, and you can scuba dive 100, 200 feet. So you can go a little bit of the way. So let's go the other way. We're not going to go down. We're going to go up. So instead of going down 100 feet, now we're going to go up. The closest you can get on the ground to space would be Mount Everest. So you can go to Mount Everest. And the atmosphere is thinner. Obviously, the terrain is different. It's cold, weather, pressure. So you can kind of take all of those readings. Now, obviously, Mount Everest exists, and that's the closest a normal person can probably get to space. Now,
Okay, so
the next step is you can get in a plane, and you can go a little higher in a plane, and you can, take pressure readings and see, I won't say the curvature of the earth, but you can see the surrounding terrain. You can, obviously a little higher, 30,000 feet or 40,000 feet colder. You can get into the military planes. You can go 80,000 feet. The pressure's lower, colder, different, all the different environmental effects. Now, the highest that a human has been is that Baumgartner guy, 120,000 feet. He needed a spacesuit. He needed air to breathe. Again, different pressures. Again, I won't say the curvature of the Earth. But
he didn't need a spacesuit. He didn't need a spacesuit. He didn't go to space. He needed a suit so he can breathe.
Suit. Sorry.
Yeah, pressure suit. Yeah.
Suit. He needed to be in breathing apparatus. The pressure was too low. He needed a suit for the pressure. Okay.
Absolutely. Yep.
So that again, do you accept that was real? You can't do that.
Yeah, it appears to have been
cannot
real.
go there
Yeah.
personally, but somebody else did. Took all the readings, looked at all the things. Do you accept that?
Me personally? Yeah, I accept that. Yeah. But that's just me personally. There's no proof. It's just my acceptance. Yes.
So that the highest that a human being has been is 120,000 feet, and that
actually no. There was a guy that beat him a little while after that.
Well, whatever that altitude.
But anyways, we'll go with that. Go
120,
ahead.
130, 40, whatever. That's the highest that a human has been, and you accept that.
Yep.
So I guess you didn't personally do that.
Nope.
But you accept that it's true.
I accepted it myself, yes.
Okay. But you said earlier that for this dome thing, your own personal, the only way you would accept that is true is for you to personally go there.
Right. I can't prove it. You asked me if I accepted it, if I believe it, like a thing of faith.
Okay. So.
And I said yes.
I guess that's the distinction you're making is acceptance versus proof.
Absolutely. That's what this whole thing is about. Yeah.
Okay.
Like you can accept that a man stepped on the moon, right? And I'll say, fine, that's no problem. But you can't prove that. See the difference? You can accept that. You can accept the lie told to you that I think it's a lie, but you cannot prove it.
I guess my confusion is, where do you draw the line between what you accept as just, I believe that's true, versus what you accept as evidence of truth? It's proof, I guess. Where do you draw the line between
it's logic? It's using your common sense, using the brain you were given, and making up your mind, listening to the story, and saying, does this story make sense or doesn't it?
So this whole Baumgartner thing, that there's proof of that, or you just accept that it's true?
Well, I did a whole research on that. It was actually my first debate. So I can't tell you that 100% proof. I wasn't there. I didn't see it. But I believe that it happened. It's a belief. Sheer belief.
But not proof.
Not proof, no.
So the only way that you would prove it to yourself is to do it personally.
No, if I was
He's not
there and
gonna
I
do
saw
that.
him in the balloon, I saw him going up, I was checking out the instrumentation, you know.
Yeah, none of
me,
us
that
are
would be-
going to the common line, you know.
Sorry?
No, I'm just saying to say that you would have to prove something like that to yourself. Like that's a bit difficult.
Yeah, proof. As a matter of fact, I'm on doing a proof project. I'm asking people, what is proof to you? That's a whole different subject. That's, yeah,
That's a
exactly.
good question.
What is proof?
Yeah. Essie, would you say that people have varying levels or degrees of proof? I could be shown something and I accept it as proof, but you want a higher degree of proof?
Of
You
course,
you want to see a bit?
Yeah, of course.
Right.
It's, yeah, all the way, yeah.
on a trial, you see that every day. There are some people who
But-
believe that the proofs, and some people who don't believe. That's why they have to argue
Yeah.
at the end of it.
But then, is it fine for the people that don't share the same levels of proof as you? Like, if someone is showing something and they accept it and you don't accept it, does that mean that person that accepts it is not open-minded, not a free thinker? You know, is there anything negative about them, or it's fine that they have a lower threshold for proof than you do?
This is how I take things, right?
Mm.
I don't judge anybody, right? You can believe anything you want. I say this all the time. You can believe anything you want as long as you convince me of your belief, right? So your proof may be different than my proof, right? And I accept that. It's not a problem for me. But don't try to convince me, for example, that man stepped foot on the moon. Don't try to do that. It ain't gonna.
Is it possible? Could someone
about this
convince
kind
you
of-
of that?
It's
Hey,
not gonna
Montreal,
go
what
good
about
for
this?
you if you try that. I'm telling you, it's not gonna be good
But I'm
experience.
asking, is it possible? Could someone prove to you, Montreal, that man has been to the moon? Or do you think that's something no one will ever prove to you?
Well,
Are you-
I think that
They
I was
haven't
talking-
up until now. Let's put it that way. They haven't up until now.
I think
But it's
that kind of
possible.
goes back to what I was asking him earlier. To me, the only way he would accept proof that man has been on the moon is for him to personally go to the moon.
Obviously, you weren't listening when I was talking, right? The example I gave about Bob Gardner. Did I personally go up there?
No, that's the thing is. So you accept that that's true, but you don't necessarily
Well, the
have
jump-
proof that it's true. That's what I was asking earlier.
This is the problem. The reason why is probably I don't want to speak for you, but I think the reason why he can believe and I can believe that guy jump is because it's not outside of reality. It doesn't
Yes.
defy any of the
Yes.
natural laws. He's not going outside of natural laws. That's why.
Well said, Silent. Well said.
Natural, like, what do you mean not going outside of any natural laws? Like, he's not defying physics.
He's not.
He's not going to space because
He's not
space
traveling
doesn't
on a place where
Wait-
there's
wait a
a
second.
vacuum.
Wait a second. They went to Mars, guys, with their rover. So why are we talking about the moon when they have technology to land on Mars?
I mean, you still have to accept that. as
Baby steps,
faith,
my
though,
man. Baby
right?
steps. We're gonna get to Mars and whatnot. You know, we just
Yeah, but here's the thing: why isn't there any rovers on Mars or rovers on the moon if there's rovers on Mars?
yeah, they're not rovers on the moon.
There has been.
I
Yeah,
haven't
they
seen
have.
any rovers. I haven't seen any rovers on the moon, not once.
You've never heard of a lunar rover?
So if you're looking at 1969 to 1972, there hasn't been a rover like the Mars rover on the moon. No.
Like recently, or like are you saying ever?
So apparently we went to the moon with men. but we can't go back with men, but we can use machines to go to Mars. So if we can use machines to go to Mars, why don't we use machines to go to the moon and do what they do on Mars?
Because there's nothing for us on the moon. We've been there. We've explored it. It's a giant
So
rock.
there's not,
Like, what else are we gonna go do?
this is your attitude. There's nothing on the moon. Who are you, and how do you know there's
If-
nothing on the moon?
If we've been there, why would we want to go back? Like, what is there for us to go back for?
Okay, so you haven't been there with a rover, but you've been there with humans. You haven't been to Mars with humans, but you've been
Rovers
to Mars
have-
with a rover.
What
Yeah.
do you mean by
What-
rover? Do
what
you mean
rover?
like a car, or you mean a machine that isn't controlled, that's like remote controlled by
Mars
men?
rover. Mars rover. Why is
And there are
a
lunar
moon
rovers. There are
No,
lunar
there-
rovers
there
as
is
well.
no
So I just
lunar
want clarity.
rovers.
Where,
There was
Where
a
are
lunar
they?
rover, but that was a vehicle that landed with them, which still.
That's what I'm asking. Is he asking for us to send like a? Okay, so like how we have on Mars, where we just sent a machine
Listen to this guy.
and we
Your
control it
attach-
remote.
your attachment to a small occult. You're talking about the moon landing. We don't go back there because we've already been
My
there.
man,